I hope everybody knows what is Sqlite, but I try to introduce a little bit. So, basically, Sqlite is a database management system, so it is a software that somehow manages a database. I asked Wikipedia because I was not sure about the definition. Anyway, with DB, the database management system is a software that interacts with end user, and using the software you can change information inside the database. And the database is an organized collection of data, generally stored and so on. So what I found really interesting about this is this. So this is written 2,500 years ago, and it was actually a database because it was a registration of transaction between people in Mesopotamia. So, and I don't find the programmer for this, but I think it's not important. But what I think is really important is that anyway, databases are here to stay because people, the first time people write something, it was to record data, and almost 5,000 years ago, we are still using it, so probably we have to deal with database for a long time ago. So why Sqlite? To make it simple, I consider two big families. We have SQL database and NoSQL database. Recently, NoSQL databases are growing as a usage. I'm thinking to MongoDB. But okay, among SQL we have two big classifications. One is database server. So this means that you have a server that is a different process running somewhere, maybe not in your machine, maybe on another, also not in your country. And of course it is very powerful, very solid, can handle thousands transactions together in the same time. And on the other side, we have a database library that is in process. So this means that that is basically a library inside your application. So you have very, very low latency. So you don't have to ping something that is across the ocean. It's really a matter of hundreds of microseconds to have an answer. So this generate a very low latency. About the speed, it depends. Of course, it depends on the hardware you have. And about the implementation, if you use in-process database in your application, it is simple because you have no excuse. You cannot say, oh, okay, the database engine is down, it's not my fault, there is the antivirus blocking the communication or something like this. Okay. So now, I want to show you how we can integrate an SQLite database into Qt. Okay, the first suggestion is to don't do it. Use this application that they already did, so you can use and test it. This is the DB browser for SQLite. It is written in Qt, of course, and you can use to create database, test, query, test what you want to do, and it is faster as a learning, let's say, a learning curve instead of writing your code, testing, debugging, finding why it's not working, and so on. I think this is a very helpful tool to develop this kind of stuff. But anyway, the integration is quite simple. You just need to add the module SQL and you need to import a few set of stuff. I don't know, someone can tell me why I have this annoying message from the code controller. What's the name of the new, okay. Really? Oh, okay. Okay, I try. Byte, okay. So, when I start using with this integration, I found a little bit strange because almost everything can be done using static methods. This, in the beginning, was a little bit surprising, but later I understand this is because basically SQL is not a database you can use to, to write into the database from different process, of course, because you are in process, but also from different threads. It's not think it in this way. So you have just one point, one access point, and this is unique. And so you cannot think to have 10 threads writing to the same database. So for this reason, I think this is the main reason why they use this static approach. So everything is static. So basically, adding a database and removing a database is just a static method, and you have a description. Usually, I use the file name, the full file name of a database, so it should be unique. And in this way, we can add the database and remove it from our application. So in the beginning, it looks a little bit strange, but in the end, it's really easy to use. Okay, now an example. And of course, sorry, but usually I work with images, so it's still an example about images. And so I, again, try to create a database to index, to create an index for 1 million images. 1 million for me is a kind of target to work with. And consider that we use a Python script to create these images. And the Python script takes 6 hours to do it. So 1 million images is a big number, not something that can be done during the lunchtime. So you need to prepare a little bit everything, because otherwise it can last forever. And in this case, I split images in folders, so I don't overload the file system. And I keep very simple images, just a gray with a number printed inside. I use a Python library that's called Pillow, and I generate these images. The total file is the total size of a folder it's 4 GB. But consider if it is 1 million image, it takes 10 to 15 minutes just to make a copy of this folder. So, okay, this is my introduction. Basically, I write this book a few years ago. I'm still using Qt since 2000. And of course, I'm working on another book very, very quickly. And I just 3 years late in my schedule, but okay, sooner or later we'll be ready. Okay. So next step is, how can we write image information into the database? I want to start from the simple part, so I want to write just the path, the name, the timestamp, and the size of the image. To create the database, I use this application, and I create this simple table. I call the table images. Inside the images, we have a relative file path, file name, file size, that is an integer, and created, that is the timestamp, it is a text. So I take the timestamp and I convert it into text. So, to work with data inside the database, we need to use the query. And to use a query, the simple way is to use QSQL query, that is a wrapper. And to init the query, you just need to know the database path. And then, just using the static method database, you get, again, you get a query that is connected to that database. Of course, when you use this call, the database you have to already add the database to your application, otherwise it's not working. And automatically this call open the connection if it is not open. The next step is to scan every folder and every file, and for every file I generate this query QSQL, that is a string, but basically it is a script in SQL language, and I pass this script to this method that is exec, so the query can be executed, and if there is an error, I print an error just for my use, for debug. Okay, from this point I think it's really, well, I don't know if you know what, is it strange or is it, you know, okay. Everybody knows what is Sqlite? Yeah, okay. So, with speed, this is the first approach. I use Core i7, 8th generation, 4 GHz turbo boost, and I get a very, let's say, scary number. I get 5.4 milliseconds for every image. So if I estimate how long it takes to index all 1 million images, it takes 1 hour and 30 minutes. That is too much for, let's say, I can do also in Java something like this. So I don't need Qt to go to this speed. And so, starting from this, I try to find a way to optimize the writing process. First, I try to understand what is the limit. So let's say I want to understand if the problem is the writing the database or is calculating the query, the SQL script. So I remove the part where I write to the database and I run just the code, and I see that we can arrive at 50,000 images per second. That is a little bit better. So it is a decent number. But this is the limit. For sure, I expect to have something worse than this. And this part, it was very boring because I have to try, I try all the possible combination of PRAGMA structure. I try to use the bind, try to use the batch execution. And finally, I select just for you just the part that I see as useful, and I skip the part where I get nothing as an improvement. The first point is this journal mode, that is write ahead log. This changes the way the database engine write the backup file. And, okay, despite the technicality behind, for me it's important is that I speed up a little bit the application, and now the average is 1.955 milliseconds, so now I am at 500 images per second. Still too much, but better than 18 images per second. The next step is to create the journal in memory. There is a file. The journal is really a file that Sqlite create, and it can be created in memory or can be created on the file system. If we create in memory, I suppose it is faster because the bandwidth with the memory is around 4 gigabytes per second or more, and the bandwidth with the disk is 400 megabytes per second. And in fact, what I see it is that I see an improvement in the speed. And again, we are growing, so now we are 585 images per second, but still far from the limit. Next step is PRAGMA synchronous off. There are a lot of this PRAGMA that can be used to change the status of the database or your database file. I found this synchronous off. This means that you don't need to wait until the library write your data into a file. But I think there is a kind of queue. This has an impact in terms of robustness of the solution. I don't care because I don't need to have a very mission-critical database. So in this way, again, I get a little bit better. So now I am 1,000 images per second. Hopefully. How fast you think we can arrive going in this way? Can you estimate where are you going to? No? So starting from 18 images per second, where we can arrive? Let me show you. Okay, now I found this, begin and transaction. Oh, this is, okay, a little bit better. So now we arrive at 8,000, was it almost 9,000 images per second. This is really simple. So you just need to declare in the beginning of your function that you start a transaction, and you have to remember that you have to close the transaction at the end. And in the meantime, the database is faster because basically it can queue many different operations and then write in one single operation. And this creates a good improvement. Then I try to play with a big number, because all the test I did before, it was just for a small subset, because I don't want to spend my life waiting for answer. And so I start from 100 images. Now I'm ready to start with 1,000,000. I create this list of experiments I did. So I see that there are some, this is the estimate processing time for 1,000,000. And you see that just applying begin and transaction can be a little bit acceptable, because 2 minutes can be okay. Considering that Python takes 6 hours to write these images, 2 minutes can be acceptable. And so at this point I try, and this was very boring, I tried to mix all the possible combination of optimization to see if I improve or go back to the result. And so, finally, I find that this was the best combination. So, synchronous off, journal mode in memory, and the begin transaction as last query. Okay. So at this point, I was really surprised, because I was able to go faster than my limit. So this, of course, is not only because of the optimization. It is also because I think probably the turbo boost, that is a dynamic changing the processor frequency, related to the fact that I'm using just one core, so one core is going faster and the other core is slowing down to keep the energy balance in the CPU. Because this operation takes almost 16 seconds, I think the transition from low to the idle frequency to the turbo boost frequency takes a little bit. So finally, I think we have this speed up. But anyway, we start from 18 images per second. I arrive to 62,000 images per second. So it's a really speed up. But it's not over. I start looking to the bind, mainly because to insert to the next step, I want to insert images into the database, and to insert images, I need to insert as binary large object, and to use binary large object, I need to use a byte array, and to do this, I need to use a different architecture. Instead of prepare a script, I use a technique that is called bind. So I need to prepare the query. I use some special code that will be replaced by the content that I want to write in the database. So, and starting from this, I use bind for every single value, and then I execute the query again. And this is again lead to a speed up. I think this is because preparing the query, maybe there are some optimization inside, so we don't need to parse the test all the time. And again, considering that we start from 18 images per second, now I reach 90K images per second. So the full database of 1,000 images takes 11 seconds. On my Mac, it takes 100 seconds. I don't know why, probably because it is a Core i5 and not so powerful. But anyway, it's way more simpler than 1 hour and more than 1 hour. So, and it is incredible. I think 90,000 images per second is very, very fast. Maybe it was not clear. 90,000 images per second. Okay. Now, I can imagine that if you follow me, you can understand that I use just text, so it's easy. Come on, it's maybe 100 or 150 bytes per row, so who cares? It's not so. So now I want to play with the icon. Basically, the idea is to create inside the database not only the name, the file, the size of the file and the timestamp, but also the small icon, so I can review it quickly, and a bigger icon, so I can review, but a little bit bigger. So I start to write the icon into the database. Of course, this creates a database that is bigger, and of course, this slows down the performance. But how much? This is the question. So I define this as icon, so 55 by 50 pixel and 320 by 200 pixel. And again, I use the DB browser to change my library, and I add this to Blob. So Blob means binary large objects. Where is no? Okay, binary large objects, and I call it icon and thumbnail because icon is the smallest one and thumbnail the biggest one. So creating the icons is, let's say, it's a little bit complicated and it's not so, I don't want to spend time on optimizing this part. So I create just one icon and one thumbnail for the first image, and I replicate the same information into the full database. Maybe this change a little bit the result of the test. I don't know. I hope not, but I can't say it now. But I don't want to test the conversion of an image from the file to the icon because it takes a long time. This part of the code, it takes more than 1 millisecond for every image, so it doesn't make sense if I have 100 microseconds on the other side. So it is completely changing. So maybe can be the subject for the next topic, for the next talk, I don't know. So how can I insert the blob into the database? Again, bind value, icon, and QByte array. QByte array, this works because QBind value accept a variant, so and byte array is one of the data. And automatically, in this way, I put a file into the database. So the performance is still, I think, incredible because it takes 24 seconds to build a database of 1 million images. Even if now the dimension on disk is 4 gigabytes, where is written? So considering that the speed of the disk is 400 megabytes per second, it takes just 10 seconds just to write the file to the disk. So we have, let's say, more or less 10 seconds to write and 14 seconds to do the indexing, to create the database. Of course, the result is 42. So it can be a difference. So 42,000 images per second. Okay. So at this point, this is the optimization phase. It's complete. Now I want to do a quick review about how we can see the database content using Qt. It is not complicated. So I want to create something like this. Well, the icon here is not so, but basically this is a really icon. In the top there is written a number, and so I want to achieve something like this. This is basically a table view. The table view is alimented by a query, and the query is inside a SQL query model. And what I want to show is also how we can convert the binary data from the database into an icon using a delegate. So, okay, we have a QSQL query model. That is the model for the database. We connect the model to the table view. This is the standard. I add this stretch last section just to force the table to fill the full area on the screen. And then we have this set item delegate. Then later I show you how I created, but it's really simple. Basically, what we need to do is to re-implement the method paint into the icon delegate, and if we have an icon, we do something. If we don't have an icon, we use the standard method. And of course, I need an event, so I have a button that pressing the button refresh the content of the table. Writing the delegate is quite simple. I don't know, maybe it's simple, maybe not. It is a little bit something. I found some example and I understand how to do it. But basically everything is done by this draw PRAGMA, and I apply this, let's say, heuristic information. So if I have a record that is bigger than 400 bytes, it should be an image. If not, if I have a very long file name, this don't work, because probably try to paint as an image. But anyway, in this way, if it is an image, I do the paint, the custom paint. If not, I use the standard delegate, and I do the standard paint. And I place the icon into the area reserved by the option.rect.sites. So I rescale the image and I put. So for this reason, we see the icon and the thumbnail with the same size. Maybe I should do something better, but I just try to fill the space on the table. But anyway, again, every time I'm really surprised how things can be really simple. Let's say, maybe not simple, but it takes very few lines of code to do many things in Qt. Last point is, if I want to search an image, what I have to do. And so here it takes a different query sentence. It is a select star from where. So I select everything from the table images, where file name like. There is this like, how to say, like operator that I find is very practical, because it don't make just a matching on the character, but is a pattern matching, so it can search the string in a different place of the text. So I apply the search to file name, and then I apply the order by file name and in descending way, in descending mode. And again, here it is the query is simple. So I create a query, I execute the query, and then I review the result using this while q.next. In this way, I select a query record, and from a query record, for instance, here I print a string. But I add this just to show how it is the result of a query, because practically I don't do it. I just give this query to the QSQL SQL query model, and automatically this feeds the table, so I don't need to do anything. And this is an example I try to run. So you see, because this like function is matching 1, 2, 3, 4 in different position. Okay, this is not the case because I use .png, but anyway, we can have okay, more instance of more matching, depending on. Okay, now the last point is how long it takes to do this search. And it takes 12 seconds. And again, something that I don't like it. So I start to check how to speed up also the search. Because anyway, 12 seconds is something I cannot accept. It's too long. And to speed up is very simple. Again, using the QSQL DB browser, I add an index to the column file name, and this automatically speed up the research. This is a little bit tricky, let's say, because the important thing is to create the index after we put all images into the database. Otherwise, every time I add an image, the database needs to update the index, and it takes a long time and degenerate the performance. So the right approach is to remove the index, update everything, add the index, and finally, adding the index, I don't make any test because I do from this application, so I cannot have a measurement of the time, but it is something like 1 or 2 seconds. So it's not nothing. It takes a while, but it's not an unmanageable time. And I think, okay, yes, and the result is using the index, it is few milliseconds. It is difficult to tell exactly the value because it depends on how long is the string, how long is the file name, but I move from 12 seconds to less than 10 milliseconds, so it's nothing. So now the answer is incredibly fast. Okay, questions? Attenzione. I think we have a long space.
Thank you. Congratulations for your result. It's very impressive. My question is, how much time did you spend to reach these performances? At least for the first part, I mean the SQL
optimization.
Optimization only.
Oh, yeah. It takes time. Let's say I did it 2 years ago, and I forget it, and then I do systematically just to prepare the presentation, and I spend, I think, I don't know, 3 days of work on doing this, because I try on small set, and then a small set, then I try on the big one, and then I collect a result, and I find, yeah, well, not 1 week, not 2 weeks, but 3 days. It takes 3 days to do this optimization. And also what I see, it is probably, you can have different results depending on the platform. I see probably on the Mac there are some optimization that works better than what we see on Windows, or I think. Basically because the file system is different, so I can imagine that some file systems are more optimized for certain operation and some other file systems are different. But anyway, I think it's something that is working because 10 seconds to index all the image, who cares? So it's nothing. And also 25 to put all the icon inside, but scrolling the image and just getting the icon back from the database in 2 to 3 milliseconds, I think is really fantastic.
Did you try to, did you add the indexes after or before inserting
No, absolutely after. Well,
did you try to insert with the index
No,
active?
I don't do this test. It's the old test I don't try this. Not this time. I remember when I do the reapplication a few years ago, I found this problem. But when the index is in, you have a drop in the performance. I cannot tell you if it is 10 times lower or just 2 times lower, but I remember this.
And the last,
Sì, sì.
have you measured the time to add an index with 1 million rows in the database?
No, I don't measure it. I have just a feeling because I create the index directly from the application, and so I don't see. Maybe there is a log and a timestamp, but I don't see it. But my feeling it is something 1 or 2 seconds, not for sure not 100 seconds, for sure not 1 hour. It's 1 or 2 seconds.
Thank
so
you.
on top of 24 seconds, can be 26, but okay.
I have 2 questions. What about updating and deleting a lot of images? And the second one is the index, you are doing it after, but on the client side you cannot do any index, if I understand correctly. If you have the database on a different, I don't know, client size.
But wait. Okay. About updating, I solve the problem in this way. I drop the table because I have a file system. And also, I remember again from a previous implementation that it was faster to drop the table and rebuild everything instead of searching for every file, search if the file is already in or not, and then update the database. And the second question, sorry? No,
The selecting will not work faster if if you are working on the client side. Let's say you, I don't know, you gave the program to someone and he is making the database and working with it. The select indexing it will not work on their side. Do you have any other solutions?
No, why you say on the client side? Sorry, I don't understand this point. Because basically the database is in process, so I control everything about the database.
Yeah, I understand, but my question is how can you speed up the selects on the, I don't know, client sides, because you are doing this locally. But if you have a program and you are giving it to someone else, he is working with your database. He will not do the indexing and so on. He has to do it manually.
No, okay. Well, yes, maybe I understand the point. My idea is at the end of the index of inserting the images, to add a step to create the index as part of the indexing of the full folder. So no, it's not I jump into this during the test for reading speed, and I just don't move it in the beginning just because I do this as the last part and I see this. But my idea is to put the index exactly at the end of the inserting phase, and also drop the index before insert, and then add the new index. Well, of course, this is a situation where we don't care about data inside the database, so we rebuild everything every time. So, and of course, it's not a situation that every application can do in this way. Is it okay?
Hi. Do you have any insight on why it takes so much longer to reindex the database instead of creating a new index? Is that because the index is done concurrently or something?
What I read it is yes, because the index is done concurrently, and basically when you insert a new line, there are two operations. One is insert the line, and one is update the index. And because you don't know, well, in this case probably it is also special because the file system already have all images sorted. So maybe it is there are some simplification because of this. But I think if images are really not sorted, so the system has to find the right position in the index, and I think this can take. I don't think 100 milliseconds, but probably 1 millisecond for every image when the index is long can be possible.
Any other question?
It's a question that not so related probably to this talk, but to the SQLite in general. When you work with a high quantity of data, for example, 1 million images, and let's suppose you have a kind of master SQLite file, which is the source, and my client, let's call it client SQLite database. Is there any best practice to see which records are different from the master and the client, let's say, so that I can update only the updated records, deleted or added? I don't know, add an hash or something like that to the records?
I don't know. Maybe there is something, but I don't know. I think, well, the only one thing related to this I know that is when you write to the database, there is this journal file that contains the modification, so maybe this modification can also apply to another database. I don't know, but I don't know this for sure.
Okay. Thank you.
Okay.
Thank you again.